So we want to understand how to find the inverse of a non-bijective function. When you're talking about functions, let's say you have got the set of x values, the set of y values. Okay, so we're going to have them like this. The set of x values is called the domain. We also call it the input values, that's called the domain. The set of y values is called the codomain. So let's say here if we have got a, here we've got b, here I've got c, and then you have got 1, 2, 3. And then we have got this relation that we are able to see. So because you can see that in y, everything that is in y is paired to something that is in x, meaning that the y values is going to be called the range. Now, if let's say we had a 4 here in y and it is not paired to anything in x, then we'll not call this as a range, we're going to call it the codomain. So, when you have got a function like this one which you are able to see, each set of x value is related to some y value. In a case like this one, you can see this function, all the elements in x are related to some element in y. This is called a one-to-one function. The other name for a one-to-one function is this is an injective function. Okay, Madam Sarah, you can just switch off the microphone. Okay, thank you. So a one-to-one function is called an injective function. So at times you can also have an element here. As long as it is not paired to anything that side, this is still a function, alright? But if you have got an element here in x which is not paired to anything this side, that is not a function. So for this to be a function, all the elements in x should have a pair in y. But sometimes not all the elements in y is going to have a pair. So this is an injective function or a one-to-one function. We can have another scenario where I've got x and then we have got y here. So let's say I've got a, b, c, and this side we have got 1, 2, 3, like that. So let's say for this function, this is paired with that, and then we have got something like this. This function that we're able to see here, you've seen all the elements in x have been paired. By definition, if all the elements in x have been paired, then that is a function. Okay? But you can't have one x value going to two y values. Then that is not going to be a function. But you can have one y value going to two x values, that will still be a function. Now, because we have got an element here that is not paired, you can see we have got a 2 in y that is not paired. So this function is going to be a function which is not on 2. Now let's say I put d here and d is paired to 2. So you can see all the elements which are in y are paired. So such a function is called an onto function. The other name for an onto function is called a surjective function. That's the other name. If you hear a function is onto, just know that all the values in y are paired. It means there's no value which is not paired. Now, if you have got a function which is injective and surjective, such a function is what we call bijective. Okay, such a function is called bijective, meaning that for this function that we are able to see here, it is not surjective. Why is it not surjective? Because we have got 4 which is not paired. That is the reason as to why it is not surjective. But it is injective. Why? Because it is one-to-one. So if I remove this 4 here, you can see that all the elements in y are paired, meaning that this function is going to be surjective and it is also injective. So because it is both surjective and injective, then we say that this function is bijective. Before I proceed, is that okay? So this function I've written here is bijective, meaning that it is a one-to-one function and then all the elements in y are paired. You don't have anything that is not paired. Do you have any question before I proceed? Do you have any question? Sarah, is it clear? You can just open your mic and be able to speak if you have something. Alright, so if this is okay, now if let's say this is the function f of x, if you want to find the inverse of this function, if you want to determine the inverse of this function, what happens is the x values and the y values get to swap. Okay, so 1 2 3 is going to come here and then a b c comes here. So what was the domain becomes the range, what was the range becomes the domain. Remember, the set of x values is called the domain, the set of y values is called the range. So in this case, what was the domain will become the range. So the 1 2 3 was the range, so it becomes a domain. Okay, and then the ABC was the domain, it becomes a range. So this is what happens when you find the inverse of a function. Now let me start first with a very simple example of a bijective function. We find its inverse. So let's say we have got a function f of x which is equal to 2x minus 1 divided by, let's say, 3 minus 4x. You want to find its inverse. So this function is a bijective function. It is one to one because you don't have any square, right? So if you don't have any square, you don't have any cube, then that's a linear function. Find the inverse. We know that to easily say this is y is equal to 2x minus 1 divided by 3 minus 4x. Now our aim is to make x subject the formula. So we do the cross multiplication. We are going to get 3y minus 4xy, and that is going to be equal to 2x minus 1. Everything with x, take them to the same side. I'm going to gain this term, take it this side because it has got x, and then I'll get 1, take it to the other side, to be 3y plus 1 is equal to 2x plus 4xy. So from here I'm now going to factorize out x because it is common. So I'm going, yes, Sarah Suilanji. You can go on. Do you have a question? Alright. So from here I want to have x as a subject of the formula. So I'll divide both sides by 2 plus 4y. So we're going to have x is equal to 3y plus 1 divided by 2 plus 4y. Therefore the inverse, f inverse of x is going to be 3x plus y 1 over 2 plus 4x. So just change where there was y, you now put x. I hope this is okay. Please, if you are not, be free to ask. Now this is not what I want us to look at. We want to understand how to find the inverse of a quadratic function. A quadratic function is in the form x squared. So for this quadratic function, it goes like this. So you can see that if you have got y1 value, let's say you have got 4, you are going to have two x values. Maybe let's say positive 2 and negative 2. So because you have got two x values for the same y value, meaning that this is not a one-to-one function. Because it is not one-to-one, meaning that it is not injective. And if it is not injective, then it can't be bijective. So this is the one we want to find the inverse for. Now, how do you find the inverse of a function that is not bijective? What you do is you restrict the domain. Okay? You restrict the domain. The domain is a set of x values. So if you look at this, starting from this point, here you have got positive x values. This side you have got negative x values. That is what we call the domain. So we are going to just get the values of x which are positive. So meaning that make the domain of this function to be only from 0 up to infinity. So what we have done is restricted the domain. Meaning that for this function, I'm going to remove one part. Okay? I'm going to remove the part that goes on the negative side. So the way I'm going to draw it is I'm going to just draw this portion, which is positive. That's the meaning. Otherwise, you can't find the inverse of a quadratic function like that without restricting the domain. Now from here, I can find the inverse. Okay, so this was I was supposed to write f of x. So I'll now say this is y is equal to x squared. Now remember, when you are finding inverse, your aim is to make x up to the formula. So square root both sides. And you know that when you square root, the positive or negative comes in. So the square and the root go. So x is going to be equal to positive or negative square root of y. Therefore, f inverse of x is going to be positive or negative square root of, now we put where there is y, put x. Now, the way we've written positive or negative, it will be for a radical function. I'm going to teach on how to do radical function because you're supposed to know each of these. Okay, when you have got square root of x, the equation for the graph for this one looks like this one, like this. When you have got negative square root of x, it looks like this. Now a function and the inverse, you can draw a straight line between them like that. So since we restricted the domain, meaning that we are only going to pick the positive side of this inverse. Therefore, the answer you need to write, the inverse of this function is just going to be positive square root of x. Because the way it is like this, then the graph is going to be like this, positive or negative. You are going to have the red one on top and the red one down. And this graph you can see in red is not a function. You want your answer to be a function. That is why you restricted domain. So the answer is going to be this one. So this is how you find the inverse of a quadratic. Let's look at another one. Let's say we have got this quadratic and they've asked us to sketch it. I mean to find the inverse. Now the first thing, remember, you need to restrict the domain. So, meaning that you need to know how the function is going to look like. Now when you have got a quadratic, these values that you get to add or subtract from x, they shift the graph in the x direction. So the x minus 1 equate it to 0. You are going to find that x is equal to positive 1. Meaning that your function is going to start from positive 1. And then it is supposed to go this side and this side. That is how the quadratic goes. Okay. Now to restrict the domain, you are going to only pick the portion which goes to the right. So meaning that I'm going to remove that portion which goes to the left. So I've restricted the domain. So the domain which is restricted is only starting from 1 up to infinity. So this function will just pick for the set of x values which are like this. Meaning that since this is the domain of this function, if you find the inverse, this should be the range of the inverse. Remember what I said at the beginning. So now we can find the the inverse. So our aim is to make x a subject of the formula. How are we going to be able to do that? Say y is equal to x minus 1 squared. We are supposed to square root, so I can write it as x minus 1 squared is equal to y. So let's square root both sides. Remember, square rooting brings positive or negative, so the root and the square cancels. Going to have x minus 1 is equal to positive or negative y. I'm going to take, square root of y. I'm going to take the 1 the other side. So x is going to be 1 plus or minus square root of y. Now, when you have got a positive for a radical function, this class, I like teaching radical function. You are going to understand how to sketch, very easy. We are going to have that class for those who are going to be registered with us. So, because we restricted the domain of the function itself only positive, meaning that the inverse, f inverse of x is just going to be 1. We'll just get the positive part, and then square root. Where there is y, we put now x. Actually, this function which you are able to see here, the inverse, if you find its range, okay, it is going to be the same as the domain of this one. If you find the range of this one, which is here. So I will not teach you how to find that, because that will be a interesting class. Let's look at another example now to find the inverse of a quadratic. So let's say we have got f of x, which is equal to 4 minus x plus 2 squared. You want to find the inverse of this function. You can actually try to sketch this graph. So this constant which is added to a quadratic shifts the graph in the y, meaning that the graph is being shifted to positive 4. And then equate what is inside here to 0, you are going to get negative 2. So meaning that the graph, the turning point is going to be at negative 2, 4. But because there's a negative attached to the part which has got x, meaning that the function is going to have a maximum. It will go down like this. Okay, it's going to go down like that. Now, I'm only going to restrict the domain to pick the portion which goes to the positive side, meaning that I'm going to remove that part. Okay, so I've restricted the domain. The domain of this function is the smallest x value you can have is negative 2. The highest, it is going to infinity. So this is the one now we are going to find the inverse. So we're going to make y subject the formula. So we're going to equate f of x to y. So y is going to be 4 minus x plus 2 squared. Since this is negative, I'm going to take it to the other side, it becomes positive. X plus 2 squared. And that is going to be equal to 4. This y, I'll take it to the other side, becomes negative. And then square root both sides. So we're going to have x plus 2 being equal to positive or negative square root of 4 minus y. Take 2 the other side. So x is going to be 2 plus or minus square root of 4 minus y, meaning that the inverse of this function. Now remember, we've restricted the domain, so I'm just going to pick. If you look at this one now, this function, this domain you can see here should be the range of the function that we want to find. Okay, so meaning we are going to pick 2 plus or minus, sorry, not plus or minus, we just get to pick the plus square root of 4 minus, where there was y, we put x. Now if you want to find the domain of this function, now for the range of this function, sorry, this number, it will start from this number that you're able to see here, going to all positive numbers, but this was negative 2. Let me see the way I took. Actually, when you take this to this side, it's supposed to be negative, so that's why I'm doubting this answer. So this is going to be negative. Now it is correct. This is going to be the inverse of this quadratic. It's very easy to find the inverse if you know this. Now, if they've given you a quadratic that is in the form that we know, let's say they've given us f of x, which is equal to x squared minus 2x, let's say plus 4. And they ask you to find the inverse of this quadratic. Before you find the inverse, the first thing that you need to do is you need to complete the squares. Remember, when you're finding the inverse, you're supposed to make x a subject the formula. So for this one, there is no way you can make x subject the formula. So make sure that you complete the squares. Now, completing the squares again, I'll show you a very simple method. Look at x squared. Just make sure that the number in front of x squared is 1. Now for this one, it is already 1, so there is no need to worry. The next thing that you do is you look at the number that has got x. Okay? The number in front, find its half. So what is the half of 2? That is 1. So what you do is we are going to write in brackets. I'll write this x, I'll remove the square. And then I'll find the half of negative 2, that is negative 1. Please carry with a sign. Okay? Now I'll not put x there. And then I'll put the square outside. And then always put a minus here, please, always. And then get this same number which is here, the half of this one on top, the negative 1, you square it. Negative 1 squared is positive 1, and then plus 4. Just write the 4 at the end there. So what I've done is I've completed the square. So this will give us x minus 1 squared, negative 1 plus 4, that's positive 3. I've now expressed it in the right form, so we can actually sketch this function. So the 3 that we are seeing shifts the graph up, and then if we equate the x minus 1 to 0, we're going to find positive 1. So meaning that the turning point is at 1, 3. But because it's positive here, meaning that you are going to have a minimum, like that. But I'm going to just get the portion which goes to the positive from the turning point. So this graph, I'll restrict the domain to only this part. So from 1 up to infinity. So we can now make y, we can equate it to y. So y is going to be equal to x minus 1 squared plus 3. Take 3 the other side. That will be y minus 3 is equal to x minus 1 squared. Square root both sides. So we're going to have square root. Remember, it's positive or negative. Y minus 3 being equal to x minus 1. Take 1 the other side. So this one will come in front. So that will be 1 plus or minus square root of y minus 3 is equal to x. So therefore f inverse of x is going to be 1. We'll just get a positive square root of x minus 3. If you find the domain, the range of this function, it will be 1 to infinity, which is the same as the domain of this function here. Let me give the last example on how to find the inverse of these quadratic functions. Let's say you have got y is equal to 2x squared minus 4x plus, let's say, 1. We've been asked to find the inverse. Now remember, the first thing is make sure that the number in front of x squared is a 1. But we don't have a 1 here. So what we are going to do is you get these first two terms here. Please just get those which have got x. Don't get the constant. You can also get the constant, but I'll not ask you to get also the constant. Just get these which don't have a constant. Okay? Factorize out 2. So this will give us y being equal to 2, open brackets. We're going to have x squared minus 2x. And then plus a 1 at the end. Okay? Now that the number in x squared, in front of x squared is a 1, well and good. Okay, now complete the square. So we're going to say y is equal to 2. Actually, I was supposed to write f of x because this is a function. So now say f of x is equal to 2. I'll first put a big bracket here. Okay, and then I'll write a small one inside. Instead of me writing x squared, I'll just write x. And then I'll find the half of negative 2, which is negative 1. I'll put a square. And then please always subtract. You get this number which is here, negative 1, you square it, that will give you a 1. Please always subtract and then close the bracket. This thing that you're able to see inside here is the same as this part that you're able to see inside here. And then at the end, now write a positive 1. So from here, just do a multiply this to 2 times x minus 1 squared, that will be 2x minus 1 squared, and then 2 times negative 1, that will be negative 2, and then plus 1 at the end. Therefore, f of x is going to be 2x minus 1 squared, negative 2 plus 1, that will be negative 1. So we have completed the squares. Actually, you find these questions. You find this question in the exam. You're also going to find it in test 1. If it will not come in quiz 1, I don't know where the quiz is ending. But if the quiz will end on functions, you are going to find this question completing the squares. So it's there. So now we can make a very simple sketch of this diagram. So you can see the y value is negative 1. That's how much it has shifted. The x value, equate what is inside here to 0. You are going to get a positive 1. So the function, the turning point is here. You can see the number in front of the x is positive, meaning that it's going to have a minimum. So it's going to go up like this and up like that. That's how you sketch if they ask you to sketch. So the only thing that I'm going to get is a portion that is going to the positive side like that. So I've restricted the domain from 1 to infinity. So I can now find the inverse of the function. So always use the one which has been completed the squares. I'll make it be equal to y. So y is going to be equal to 2x minus 1 squared plus 1. Sorry, minus 1. I'll take 1 the other side, so that will be y plus 1 is equal to 2x minus 1 squared. Divide both sides by 2, so that will be y plus 1 over 2. That will be equal to x minus 1 squared. Then square root both sides are going to have, of course, it's positive or negative, y plus 1 over 2. And that is going to be x minus 1. Take 1 the other side, so we're going to have positive 1, positive or negative, square root of y plus 1 divided by 2, and that is going to be equal to x, meaning that f inverse of x is going to be, we'll just get a positive, so that will be 1 plus square root of x plus 1 divided by 2. So here is the inverse of the quadratic which was given, and if you find the range of this inverse, it will be the same as the domain of the function which we had at the beginning.